Good morning, fourth graders. This is your math e-learning lesson for Thursday, May 14th. Today is a review of the lessons we've done the past few days. Okay, this is 26A, the review for test 26. Okay, number 1. If Thornton can do one problem in 5 seconds, how many minutes will it take him to do 60 problems? Now you need to notice that the time was given in seconds, but in bold it says minutes because they're saying it took him 5 seconds to do one problem, but now we're going to look to see how many minutes it actually takes him to do 60 problems. So the first thing you need to do is to work with the seconds. Since we know that it takes him 5 seconds to do one problem, that's the number we need to work with when we're trying to figure out how much time it takes him to do 60 problems. So what we would say here is we have 60 problems, okay? 60 problems times 5 seconds for each problem. 5 times 0 is 0, 5 times 6 is 30. So it actually takes him 300 seconds to do those 60 problems. So now we're going to convert or change those 300 seconds into minutes. So if we have 300 seconds, okay, 300 seconds, and we're looking to change that into minutes, you need to know that there are 60 seconds in every minute. So then you would take this 300 and you would divide by 60. Okay. We can't say 30 divided by 60, so we have to say 300 divided by 60. Again, you need to think back to your basic facts, and if you recognize here that 30 divided by 6 is 5. So 5 times 60 is 300. Okay, and this is your number of minutes. So it took him 300 seconds to do 60 problems, and then we converted that. We changed that into minutes by saying 300 seconds divided by 60 seconds in each minute. It will take him 5 minutes to do 60 problems. All right, let's go on to number 2. Number 2, there's an A and a B. What is the area of this rectangle and what is the perimeter of this rectangle? You need to remember that area is length times width. The length of something times the width of something will give the area. Here we have it, 10 inches times 5 inches. 10 times 5 equals 50. So that's 50 inches. However, it is area. Whenever you're doing area, area is always number of square units. The number of square units, because what you're saying is if you divided up this rectangle, you can fit 10 squares going across and 5 going up and down. Remember that area is the number of square units that covers the surface. All right, so this label here would actually be square inches because it's area. So the area of this rectangle is 50 square inches. And then B, 2B asks, what is the perimeter of this rectangle? And perimeter is total distance around a figure. Total distance around. So if we have 10 inches here, we have 10 inches along the bottom. We have 5 inches down here. We have 5 inches over here as well. So we have 10 plus 5 is 15, and another 10 plus 5 is 15, and 15 plus 15 is 30. So the perimeter is 30 inches. Area is the number of square units that it takes to cover the surface, and perimeter is the total distance around a figure. Number 3. Gilbert earned $48. If he saved 5/6 of what he earned, how much money did he not save? All right, so now this is a multiple step problem. And then we're going to need to be very careful because now it's not asking for how much he actually saved, even though it says he saved 5/6 of what he earned. The question is really asking for what he did not save. So let's start out step by step. Remember, you take one step at a time. And so here we have a fraction of a group because it's 5/6 of 48. Okay, only in this case it's $48. It's money. So it said that Gilbert earned $48 and he saved 5/6 of that. How much money did he not save? So he saved 5/6 of $48. Well, how do we figure out what that is? Remember, fraction of a group, you draw your rectangle, okay? And in this case, it needs to be divided up into 6 equal parts. Okay. Let me make this a little bit smaller so you can see it. 5/6 of 48. Okay, so there's our rectangle divided up into 6 equal parts. Now, to figure out what goes in each part of that rectangle, we divide 48, and again in this case $48, divided by 6. And you know that 6 times 8 equals 48. So this would be 8 in each spot. Okay? Now, 5/6 of 48 would mean 1, 2, 3, 4, 5 out of the 6. 5 out of the 6. However, it's not asking us how much did he save. If it asked us how much he saved, we would have to total up 5/8 because 5/6 of 48, each sixth is $8. But it's only asking for how much money did he not save. Well, if he saved 5/6, we know he did not save 1/6, and 1/6 is $8. You knew that back here when you divided $48 by 6, $8. Each sixth is $8. So he actually did not save $8. Okay? He did not save $8. Okay, number 4, find 4 equivalent fractions for 2/3 by multiplying by 2/2, 3/3, 4/4, and 5/5. So we want to find equivalent fractions for 2/3, and they're telling us what they want us to multiply by. 2/2. They want us also to do 2/3 by 3/3, and they want us to do 2/3 by 4/4, and 2/3 by 5/5. Now, this says when you are looking for equivalent fractions, you can multiply the fraction by a fraction named for 1. So you can use any fraction named for 1 and multiply it by the fraction you're given, and you'll come up with an equivalent fraction. In this particular problem, they want you to come up with 4 equivalent fractions, but they're also telling you what fraction names for 1 you should use. 2/2, 3/3, 4/4, and 4/5. So you simply just have to do 4 multiplication problems and come up with those answers. So 2/3 times 2/2, 2 times 2 is 4, and 3 times 2 is 6. 2/3 times 3/3, 2 times 3 is 6, 3 times 3 is 9. 2/3 times 4/4, 2 times 4 is 8, and 3 times 4 is 12. And then 2/3 times 5/5, 2 times 5 is 10, and 3 times 5 is 15. So we ended up with 4/6, 6/9, 8/12, and 10/15. There we have the 4 fractions that are equivalent to 2/3. Okay, and all we had to do was multiply by a fraction named for 1, but in this case, they very specifically told us what fraction names for 1 to use. Number 5. Okay, number 5. Trang's 7 cats weigh 8, 9, 11, 11, 12, 12, and 14 pounds respectively. What is the average weight of her cats? Now, usually when they use this word respectively in a problem like this, it's usually if, let's say for example, it says Trang's 7 cats, and then they listed the names of the 7 cats. And then they said weigh 8, 9, and so forth respectfully. That would mean that in the order that the cats were named, and now you take the order of the weights and you match them up. So whatever cat was listed first would be the one that weighed 8 pounds. The cat that was listed second would be 9 pounds. The cat that was listed third would be 11 pounds, and so on. That's usually when you would see this word respectively used in a problem like that. It means in the order in which it was given. Okay, in this problem, they don't give us any names. They just say, okay, well here, these are, the 7 cats, and this is how much they weigh. Okay, now, what is the average? Well, you need to think back. How do we figure out an average, a mean? Okay, we do that by adding. Okay, we're adding all of the cat's weights. So we have 8 pounds. We have 9 pounds, 11, 11, 12, 12, and 14. And so we need to add those up. All right, and when we add, we have 9 plus 1 is 10, and we have an 8 up here, and 8 plus 2 is 10, so that's 20. We have 24, and 2 is 26, and 1 is 27. And then 2, 3, 4, 5, 6, 7. So we have that the weight, or actually, the sum of the weights is 77. Now, to figure out an average, you take your sum, you take your total, and you divide by the number of add-ins. In this case, we added up 7 amounts, 7 weights. And now we divide 77 divided by 7 equals 11. So we would say the average weight of her cats is 11 pounds. Now, you know that average means, in this case, some might weigh less than 11, some might weigh more than 11. Okay, but when combined and averaged out, we would say the average weight is 11. Number 6, use words to name this number. Now again, there is a comma here. There's also a decimal point, and then there's just a period at the end. So don't be confused by the period at the end of the sentence. So you have a number like this. Oops. Okay, so this is what your number is. This is 13,916, just like always, your regular whole number, 13,916. A decimal point is where you're going to say and then because there's only one place to the right of the decimal point, it is tenths. Okay, one place to the right of the decimal point is tenths. So this is 13,916 and 2 tenths. And 2 tenths. And so that's how you would write it. 13, and of course when you get to the comma, that's thousand. So 13,916 and then you would write and 2 tenths. Okay, let's take a look at number 7. Number 7. After spending $3.50 on a ticket and $1.55 on popcorn, Jill still had 95 cents left. How much money did she start with? So this is a little bit different than what we've done before. This is how much she spent. This is what she had left. So what did she start with? Well, she spent $3.50 on a ticket. She spent $1.55 on popcorn, and she still had 95 cents left. How much money did she start with? So in order to figure out how much money she started with, you would just simply add what she's already spent and what she still has left. 5 plus 5 is 10, 9 plus 1 is 10, 5 and 5 is 10, 10 and 10 is 20. 2 plus 3 is 5, plus 1 is 6. You bring down the decimal point and the dollar sign, and you know that she started with $6. Right, number 8. Number 8. BJ rolled a number cube. What is the probability of rolling an even number, rolling a 7, rolling a number less than 6? Okay, what is the probability? Remember, you can do probability or you can do the chance. Probability does mean, the chance or it's the likelihood of something happening. Okay, so what is the likelihood of rolling an even number? What is the chance of rolling an even number? What is the probability of rolling an even number? But you do need to know that when you are specifically asked for the probability, then you must give your answer in the form of a fraction. If you are asked for the chance of something happening, you give your answer in terms of a percentage. So a number cube is simply a regular die, and you know that on a regular die you have the numbers 1 to 6. So knowing that, I'm just going to write that out here. You have 1, 2, 3, 4, 5, and 6. Those are the numbers on a regular number cube. Now, what is the probability of rolling an even number? Well, you have 2, 4, and 6. They are your even numbers. Okay, 2, 4, and 6 are your even numbers. So that gives you 3 even numbers out of 6. So the probability of rolling an even number would be 3/6. However, you need to recognize that when you have a fraction that is equal to 1/2, you need to reduce it to that 3/6. And of course, anytime the numerator is half of the denominator, it's equal to 1/2. So that's 8A. 8B asks, what is the probability of rolling a 7? Well, our numbers on the regular number cube are 1, 2, 3, 4, 5, 6. So what's the probability of you rolling a 7? Okay. 0. There's no chance of you rolling a 7 when 7 isn't one of your options. So even though you do probability or you respond to a question of probability in the form of a fraction, because it's 0, we don't say 0/6. Okay, that's just the same as 0, and we only write it as 0. So probability of rolling a 7 is 0. And then C asks, what is the probability of rolling a number less than 6? Well, then that means it's not going to be 6 because that's not less than 6, but all of your other numbers are less than 6, and you have 5 other numbers. So the probability of rolling a number less than 6 would be 5/6, because 5 out of the 6 numbers are less than 6. Okay. Let's go to number 9. Number 9 says, the first box was twice the weight of the second box. The second box was 4 pounds less than the third box. And if the first box weighed 14 pounds, what was the total weight of all 3 boxes? So this is one of those problems where you need to recognize what it is you're dealing with, and you have the first box, you have a second box, and you have a third box. And ultimately, you need to do the total of all 3 of them. So we go back and we look for what we call the obvious information. And the obvious information here is that the first box weighed 14 pounds. So we know the first box weighed 14 pounds. Now we can look to see what other information we're told. It says the first box was twice the weight of the second box. So if the first box weighed 14 pounds and that 14 pounds is twice the weight of the second box, then the second box is just going to be half of that. And half of 14 is 7. So the second box weighed 7 pounds because it said the first box weighed twice the amount of the second box. So that means the first box is 14, so the second box is only 7. And then it says the second box was 4 pounds less than the third. So the second box is 7 pounds, and 7 pounds is 4 pounds less than the third box. That means the third box weighs 4 more pounds than the second. So 7 plus 4 is 11. Okay, let's go back. After you've done that, you go back and reread the problem to make sure that you have down the right information. The first box was twice the weight of the second. 14 is 2 times more than 7. Okay. The second box was 4 pounds less than the third. 7 is 4 pounds less than 11. And then it says the first box, of course, weighed 14. Okay, and now what is the total weight of all three? Now you can add. 4 plus 7 is 11, plus 1 is 12. 1 plus 1 is 2, plus 1 is 3. 32 pounds. There's your total, 32 pounds. Okay, number 10. Number 10, 9,019 is how much less than 19,090? So you need to be able to write these two larger numbers, and it's 9,019. So that's 019. Remember, it's in the number in the thousands, so you need to have 3 places to the right of the comma. 9,019 is how much less than, so this number is how much less than the other number, and the other number is 19,090. Okay, again, 19,000, so 19 followed by the comma. To the right of the comma, you need to have 3 places for a number in the thousands. So this is 19,090. So the question is, how much less is this number than this number? And then you subtract. Can't say 0 minus 9, so we trade. 9 becomes 8, that becomes 10. 10 minus 9 is 1. 8 minus 1 is 7. 0 minus 0 is 0. Bring down your comma. 9 minus 9 is 0, and 1 minus nothing is 1. So your 9,019 is actually 10,071 less than 19,090. Okay, let's take a look at numbers 11 through 20, which you can then work out on your own. But again, number 11, you have 2 different things you need to remember. You have parentheses being used here in this equation. Remember, any problems in parentheses must be done first. The work in parentheses always gets done before the rest of the problem. So you need to work this out first. 9 and 75/100 minus 8 and 3/10. Then after you get that answer, then you can add that to the 36 and 4/10. Also, Always line up your decimal numbers by the decimal points, not by number of digits, but by the decimal point. Fill in zeros where you need to keep your columns lined up, and so that you remember, especially when you're subtracting, that if there's a digit that's missing, there's no digit in a spot, you need to put in that zero so that if you need to do some trading, you have the zero to work with, so you will get the correct answer. Number 12, you're adding fractions with like denominators. So just add the numerators, the denominators stay the same. 13, you're subtracting fractions with like denominators, same thing. The denominators stay the same, you just need to do the subtracting of the numerators. Number 14, you're multiplying. 15, multiplying. Just be careful with all of the steps, making sure you keep everything lined up so that when you go to add up your subtotals, your numbers will be lined up properly. Number 16, okay, you do this as a long division problem, of course. It's a rather large improper fraction, but set it up as a long division problem. Number 17, long division. 18, long division. Number 19, you have a rather long addition problem. The total is 78, so you need to look at what do all of these other add-ins add up to, and then after you have that total, then you can say, well, that plus n equals 78, and then you can figure out what that n is equal to. Remember, you're solving this problem to figure out what n is equal to. And then number 20, you need to change the improper fraction 39/4 to a mixed number. And of course you do that by setting it up as a long division problem, and that any remainders always become the numerator in the fraction part of your mixed number. And since you're starting out with the denominator of 4, you would use that denominator also in the fraction portion of your mixed number. All right, so please work carefully through these remaining problems. Also go back and work through numbers 1 to 10, making sure that you understand what was done, because you know the problems on tomorrow's test are going to be very similar to these. All right, so please work carefully through this. Spend some extra time on IXL and extra math. And remember that tomorrow will be your last math test, and so you're going to want to be able to do really well on that. So please make sure you understand what's here, and if you have any questions or you're not sure about anything, please make sure that you give me a call so that I can help you out. Okay? Talk to you later. Bye.